I adjusted the wrong coordinate. I changed the y max to 30. That should still be, first of all, y min should be 0 because we can't have negative donors and negative people needing donors, and I think we don't really need this higher than 5 or 6 just to be able to get a good image. We actually wanted the x max to be higher, so let's set that to about 45 just for safekeeping, so we don't have to keep adjusting it over and over again. So there it is. Oh, so there's an intersection point somewhere over here, so I'll set this to 60, a little bit more each time, and there we go. So it peaks out somewhere over here, and then there are 2 points where the number of people historically donating have equaled the number of people needing it, which is good because then you have enough donors for every person that needs one. So we could do our second calculate, intersect. Now here we have to be careful. We can still hit enter to select the first curve and then automatically jumps to the next one. But now because there are 2 intersection points, we've got to tell it where we want it to guess. So I'm going to move it closer to one of the 2 intersection points, and we'll have to do them one at a time. So one of the intersection points is at about 6.7, 3.9. So one is at 6.7, 3.9, and now I've got to go through the same process again to locate this one over here. Second calc, intersect, and again I can just hit enter, it'll automatically jump to the next curve for me, and now I just need to scroll over closer to this one. If I don't scroll far enough over, what may happen is it may just estimate the same intersection point again, but I really want to get it close over there. And now, see, it's still flashing, but it's flashing on the other intersection point. So that occurs at 49.8, 3.6. So at this point, you know, projecting models into the future is never that good of an idea, but, you know, 2050, if the trend continues the way it's going, then we would expect that in about 2050 the number of donors would again equal the number of people giving. So that's a good thing. At least this is going down, the people who need it. Maybe that shows how medical practices are a lot better. Okay, well, how would we do this algebraically? Well, we want to know where are the 2 y's equal to each other, right? So the y's are equal to each other here, and they're equal to each other here. So when does the number of donors equal the number of people needing donors? In other words, when does the y equal the y? Okay, well, the number of donors, that's given to me by negative 0.00 7x squared plus 0.42x plus, and I think it was right around 1.5. And now our linear equation was about negative 0.008x. We will get some rounding error because we are rounding so much, plus about 4. Okay, well, we notice that there's a quadratic on one side and there's a linear on the other. So to be able to solve, we could still try to get this into the quadratic form, ax squared plus bx plus c equals 0. So what I'm going to do is I'm going to move over the stuff from the side that has less on it. So I'm going to add 0.008x to both sides. And simultaneously, I'm also going to subtract 4 from both sides. So that gives me negative 0.007x squared. 0.42 plus 0.008 will be 0.428x. 1.5 minus 4 will be negative 2.5. And now I have that being equal to 0. So I can set up my quadratic equation, which is x equals negative b plus or minus b square root of b squared minus 4ac all over 2a. And I can put in my values of the quadratic form. So that would be negative 0.428. So there's my b, my a, and my c, plus or minus the square root of 0.428 squared minus, I'm going to let this run down a little bit, 4 times negative 0.007 times negative 2.5. All of that over twice the value of a, which is 2 times negative 0.007. So I'm going to simplify what's under the radical first and take the square root of it, and then I'll break it up into 2 separate, actually, we'll just do it in one step in the calculator.